So in answer to what Dr. Mukesh just put up, Barrett treats with the rule and against the rule patients differently. So this is the study we did about 62 patients where we did the Barrett calculation as well as the techniques calculation, and just to see what happens. With the rule astigmatism, Barrett and techniques was same for about 19% of the cases. It offered a lesser astigmatic correction, one step less. So instead of a T3, it gave a T2, or instead of a T4, a T3, like that, one step less in 52% of patients, and up to 2 steps less in 23% of patients. That means 75% of patients, it offered a lower astigmatic correction. And this is quite understandable, because Barrett intentionally is planning a slight undercorrection in patients with the rule, because over time the individual is going to become more against the rule, and you don't want to create too much of a flip of axis, plus the steep axis is different. In individuals with against the rule astigmatism, what Barrett does is it gives the same in 58% of cases. So T2, T2, T3, T3. It gives one step less than techniques in about 3%, and it tends to anticipate that there will be a further drift in against the rule. So one step more in about 35%, and more than one step more in about 3% of patients. So that means almost 38%, 40% of patients will get more correction than what would be suggested by the conventional online calculators. Okay, so this basic thing we have already covered. This is the formula, and before I frighten you with all the maths, what I want to do in this is not to do all this. So anybody who is thinking of running away, please relax. Okay, what I want to try is to try and demystify some of the jargon. Okay, so in sphere it is very easy. You plan for point plano, you achieve plano is 0 plus 0, 0. You plan for 1 diopter of hyperopia, you achieve 1 diopter of hyperopia, excellent, it's according to target. You plan for 1 diopter of myopia, you achieve 1 diopter of myopia, that's also according to target. So this one is simple arithmetic, and all the individuals that lie on the diagonal are excellently corrected. Individuals who are slightly undercorrected is if you plan for plano and you end up with 1 diopter of myopia, or if you plan for 1 diopter of plano and end up with 1 diopter of hyperopia, that becomes overcorrected. This again is simple mathematics. But you cannot do this in astigmatism, because unfortunately our friend the cylinder is a vector. So what is a vector? It has got something which is magnitude, which is given in diopters. All of us understand that, same as in sphere. But it has also got some amount of axis, which is the direction. So this, let us say, is 1 diopter, and if you are considering it as sphere, that's it. There is nothing more to it. But when you consider it as a cylinder, then that 1 diopter has got 1 diopter in terms of magnitude, and it has got a axis. How frightening is this? Actually, all of us are doing this every day. Everybody who is sitting here with a spectacle on his face is most likely got some amount of cylinder correction going on. We are handling vectors on a daily basis. 0, 180 is there. But the problem with representing cylinders like this for the purpose of graphical representation and calculation is that in a regular trial frame, etc., the axis that we are talking about gets represented above the horizontal and below the horizontal. So it is getting represented twice. Similarly, all points have got a mirror image below the horizontal line. So in order to avoid this confusion, when we do a graphical representation, we have 0, 180, that is a horizontal axis. We have the vertical axis 90, 270, and we have all the other points in between. Now, if we have to plot a graph, you have to be able to plot one individual only once. And this mirror image at the bottom creates a confusion. So what Alpins and Hollade did was to make a small adjustment in this one, which is called the double angle curve. So vertical steep with the rule, horizontal steep against the rule, and again on the other side there is some amount of against the rule. So how does the double angle plot work? It's exactly this thing, but they have multiplied the angles by 2. So 180 disappears and the whole thing moves around and becomes a little larger. So now it becomes very easy to represent graphically, because between 0 to 30 is against the rule, 150 to 180 is against the rule, and against the rule, all the against the rule is on the right side of the graph. Simple. And all with the rule, which was between 60 and 120, is on the left side of the graph. Okay, that takes care of axis. How do you take care of the magnitude? You have, let us say, one circle of a certain diameter, you reduce it by 50%, you get, so it is, let's say one diopter was the big circle, you make another one half size, that becomes 0.5, equally half further becomes 0.25, you make it double, that becomes 1.5. So on this you make all the plots, and if you get a plot like this, you do the residual astigmatism after multiple toric patients, you get a plot like this. This will be, the center point will be the average, which will be called as the centroid, and a cluster on the left side is a with the rule astigmatism. So you probably need to do some undercorrection, or here, or a cluster on the right side is against the rule. You probably need to plan for a little bit of overcorrection further maybe. But suppose you have a cluster like this, you know that there are systematic problems in the way you are calculating and doing the surgery, and you need to figure out where things are going wrong. To help us with this, multiple resources are available. drhill.com, our own AIOS website has got SIA calculator. So many things are available.